Lesson 11-2, two-wave frequency tables. So today we're just going to look at how to make a two-wave frequency table and then also to interpret the data in a two-wave frequency table. So first off, what is a two-way frequency table? What you see here is just a frequency table divided into three categories here. Let's warm up. So the three categories are points, tally, and then the frequency. So that you can see on the left-hand side over here, points scored per game by Dunbar High School basketball team. You can put all those boxes together, give you all the points that they scored per game. And you could put those into a table on the right-hand side and tally how many times did they get that number. So for this one, I can make a range of scores. So the first one, let's just say I did 30 to 39. Because my lowest score, according to this table, is 35. So I'm going to count in groups of 10. So 30 to 39, 40 to 49, 50 to 59, and then 60 to 69. And now I look at here, I'm going to go one by one and put a tally mark where those points land. So 45. 45 is in the 40 range, so I put a tally mark there. 53 is in the 50 mark. 53, another one here. 35 is in the 30s. 45 is in the 40s. 51 in the 50s. 58 is in the 50s. 56 is in the 50s. 69 is in the 60s. 59 is in the 50s. 57, the 50s, 63 in the 60s, 67, 60s, 56, 39, 55, 67, 52, 57, 48, 52, 55, 47, 58, and 54. So then the frequency would be the total number of tally marks we have in each category. So in the 30s, we had 2. In the 40s, we had 4. In the 50s, we had 5, 10, 15. And in the 60s, we had 4. And the frequency should add up to the total number of games that they've played. And they have 1, 2, 3, 4, 5, 25 games. So if I were to add up all these numbers, 2 plus 4 is 6, plus 4 is 10, plus 5 is 5, and then, or 15. Carry the 1, and then you got your 25. So that is just an area of a frequency table. And then we can go through and answer some questions. Right now, I'm just going to bypass this so we get right to our lesson. So a two-way frequency table. A two-way frequency table, also known as a joint frequency table or a contingency table, is used to display bivariate categorical data. Bivariate just means two variables. It shows the frequency of data from a survey or experiment classified according to two categories, with the rows indicating one category and the columns indicating the other. Suppose you are constructing a two-way frequency table based on two categories, grade level and employment. The table is constructed below for sample values. So here is one variable or one category, and up here is our other category or our other variable. We have employed and unemployed, and then we're comparing it with juniors and seniors. Then you'll notice that on the sides, on the bottom and on the far right-hand side, we have a total mark. That will be important as well when we interpret the data. So subcategories are the subcategories are the column and the row headers. So the subcategories here are the employed and unemployed. and then we'd have junior and senior. The joint frequencies are the values for every combination of subcategories. So everything inside here, those are your joint frequencies. And then the marginal frequency is referring to the totals of each subcategory. So all of these that are giving you the totals, those would be your marginal frequency. They represent the total numbers, the total number of employed, total of unemployed, total number of juniors, total number of seniors, and the total number of students in general. So moving on to the next part, our first example says unisex names are names often used for both males and females. At one point, the most common unisex names in the US were Casey and Riley, with 176,544 Caseys and 154,861 Rileys. During that time, there were 104,161 males with the name Casey and 75,882 females with the name Riley. Organize the data in a two-way frequency table. So here we already have part of the table done for us. So we have male and female on the left-hand side, and then we have the two names, Casey and Riley, on top. So now all we need to do is fill in the missing boxes. And we can do that as long as we have two out of the three numbers, we can find the third number. So for Casey's, there are 176,544. To find that, we're going to take 176,544 and we're going to subtract 104,161. And that's going to give us a total of 72,383. Now, if I were to add 104,161 and 72,383, I would get the total of 176,544. Now I can do the same thing for the total, like the males who are named Riley, by taking 154,861 minus 75,882, and we get 78,979. And then if we add straight across, how many male names do we have here? So if I take 104,161 plus or 78,979, I get a total of 183,140. And then for females with Casey and Riley names, we would have 72,383 plus 75,882. That would give us a total of 148,265. And then here in the bottom corner, I can either find this one, I can either add the totals together or the totals on top or the totals on the side. I'm going to add the totals on the top too. So we have 183,140 plus 148,265. And that should give us a total of 331,405. So here we just completed our two-way frequency table. The next step is to interpret the data. So now if I go back to my two-way frequency table, we can interpret each part of the table. Now when interpreting the table, you don't have to do every single box and explain what every single number means. We just want to get a good picture of what the data is showing. So now if I just take the name Riley and I look at the number of males and females who have the name Riley. So I'm looking at these two numbers right here, 78,979 and 75,882. They are very, very close in number. It's roughly 3,000 names or 3,000 people difference between the two. But that's still pretty close when you're dealing with large numbers. So one interpretation we could say is there are about equal number of males and females with the name Riley. And if we went back to our two-way frequency table, we can look at another one. We could also look at the name Casey. And we can look at the names here. There are roughly 30, we could say there's roughly 32,000 more male Caseys than female Caseys. Or you could have just said that there were more female or more male Caseys than female Caseys. But that would just give you a general idea of how you can interpret the data. Moving on to the next question. Ashley wants to know if there is a difference in how people in her school get their news based on age. She decides to set up two categories, age divided between teachers and students, and whether someone gets their news digitally or in print. She finds 100 people who read the news for her survey. 60 of them are teachers. So if I go into my table here that's already created for us, I know that the 60 teachers find or read their news. So if I go to the total for teachers, I'm going to put 60 here. That means there are 40 total students and 100 total people that took the survey. To her surprise, 15 teachers and 15 students still get their news in print. So if I go to the print column, 15 teachers, 15 students, that gives me a total of 30. Construct a two-way frequency table to organize the data. So I have two columns finished. I just need to find the third column, the digital column. So if I know that the total here is 100, that means I need to add a number to 30 for the digital to get to the total of 100. So if I take 100 minus 30, that will give me 70. Because if I were to add these two columns, I would get to 100. So now I think, what do I add to 15 to get to 40? So 40 minus 15 would give us 25. And then what do I add to 15 to get to 60? That would be not 30, not 35, it'd be 45. And then if I would add 45 and 25, that would give me my 70. So now if we were to actually go back to this one, if we were to interpret that, they're not asking us to interpret, we just needed to construct a two-way frequency table. We could say that there was equal number of teachers and students who read their news from print, but there were more teachers who read the news digitally than there would be student-wise. As for example one, technology. Pew Research Center released a survey that asked whether participants thought technological advancements in the future will make people's lives better or worse. Of the people interviewed, 423 earned less than $50,000 per year, and 328 earned $50,000 or more dollars. Of those earning less than $50,000 per year, 262 thought that people's lives would get better. And 240 of those who earned 50,000 or more thought the same. Organize the data in a two-way frequency table. So I have a two-way frequency table created right here. We just need to fill in the boxes. Now, if we look back at the problem, it did say that of the people interviewed, 423 earned less than 50,000. So if I look at less than 50, so this is your less than 50,000, the total amount of people who surveyed that earned that amount was 423. So that's our total here. So 423. 328 earned more than $50,000. So the more would be this category, and that would be 328. The next part says, of those earning less than 50,000, 262 people thought that their lives would get better. So 262 would go here. And then it said that 240 of those who earned 50,000 or more thought the same. So 240 thought their lives would get better as well. Now we can fill in the rest of the boxes here. I can find the total who thought their lives would get better by adding straight down, and I get 2, 10, so 502. And then going straight to totals, I can add the totals here. This will give us 1, 2 plus 2 is 4, plus 1 is 5, 4 plus 3 is 7, so 751 total people took the survey. Now to find the worst, I just take the total and I subtract the better from the total. So if I did 423 minus 262 gives us 161. And then I can take 328 minus 240 and I get 88. So 88 people who earn more than $50,000 thought that their life would get better with the technological advancements. Now if I just add straight down, I get 9, get 14, I get 2, so 249. 249 plus the 502 should give us 751. Second part of our lesson is two-way relative frequency tables, or some more with the data. So some vocabulary words. A relative frequency is just the ratio of the number of observations in a category to the total number of observations. So what we're going to do here is actually put the data as a percentage into our two-way frequency table. And to do that, we're going to find the relative frequency and the joint relative frequency. The joint relative frequency is just the ratio of the joint frequency to the total number of observations. A two-way relative frequency table or a joint relative frequency table can help you see patterns or association in the data. So to create a two-way relative frequency table, divide each of the values by the total number of the observations and replace them with their corresponding decimals or percents. What does that say? If I go back to one of these two-way frequency tables, they're saying to find the less than 50,000 better, we would need to divide this by the total of those people who had $50,000. So this would be over 423. And this would also be over 423. And then this column, or this row, would be all over 328. That's what they mean when they say divide each of the values by the total number of observations and replace them with the corresponding decimals or percents. The values for every combination of subcategories in a two-way relative frequency table are called joint relative frequencies. So what I was doing just previously with putting those fractions in there was finding the joint relative frequency. The joint relative frequency represents the ratio of the joint frequency and the total number of observations. Now I realize there are a lot of vocabulary words in here. The main thing is, how do you know how to find the different kinds of frequencies that they're asking? And on that conditional relative frequency. The conditional relative frequency is just the ratio of the total frequency to the marginal frequency. The marginal frequency is the total that we are looking at. Okay, so you're just comparing the totals. Because each two-way frequency table has two subcategories, each two-way relative frequency table can provide two different conditional relative frequency tables. So let's put this into practice. Many parents monitor their teenagers' internet usage. The Pew Research Center conducted a survey of whether parents do or do not check what sites their teens have visited and whether they are the parent of a teen between the ages of 13 and 14 or between the ages of 15 and 17. Results of the survey are shown. Organize the data in the relative frequency table by age group and interpret the data. So I have a lot of this completed for us. So they gave us the data here. And what we're going to do in part A is organize the data in a relative frequency table. So the table is going to look very, very similar to what we currently have. We're just going to change these inner boxes with a percentage. So to do that, I'm going to take the 13 to 14-year-olds, that row, and we're going to find out does check. So out of the 299 parents do check them. That's out of a total of, and the total is going to be observations we 1,060. So total of 1,060 total parents. So if I take this and I'm going to divide this by 1060, we're also going to do this one by 1060. And we're going to do this one by 1060. And all of these, we're going to do the same thing for all of them. And this one would equal 1, which just means 100%. So I'm going to write the percentages in the next slide. But so here you can see the numbers here. We're going to do 299 divided by 1060. And we get point, and we're going to run it to the nearest tenth of a percent. So three digits, but there's going to be a decimal in there. So this one would give us 28.2%. Going back to the next one, we got 140 divided by 1060, and we're going to multiply that by 100 for the percent, and that gives you 13.2%. Now, if I were to add these, that should add up to the percentage for the total. Now let's look back at our previous slide. We have 439 divided by 1060. That gives us 41.4. Now, if you were to look at this, 2 plus 2 is 4. 28 plus 13 does give us 41. Our next row, so 15 to 17. We're on this one here. So we do 348 divided by 1060. That gives us 32.8%. And then the next one, we have 273 divided by 1060. That gives us 25.8, because I'm just rounding it to the next nearest tenth. It gives us 0.2575. That 5 tells us we need to bump that up. And to save some time, I'm just going to add these two percentages. So 32.8 plus 25.8 gives us 58.6%. And then the totals I just add straight down. So 28.2 plus 32.8 gives us 61%. This one gives us 38%. And if I were to add them together, that should also give us 100% here. No, I don't double check this. This one, this would be 62%. No, I was right the first time. There was 61. It's this one. This one, since I carry the one, I forgot to do that, so that would be 39. So 61 plus 39 gives you 100%. Now that we have the two-way frequency table, or the relative frequency table created, we can use that to now answer the questions. Do more parents check what sites their teens have visited, or do more parents not check? So now if I go to here, do check is 61%, does not check is 39%. So there are more parents that do check their teens' internet usage. And that would be 61% of the parents check their sites teens have visited, compared to only 39% who do not. Based on the data, do you think there is an association between the teen's age and whether their parents check their internet usage? And explain. Well, we could say, yeah, there is. There is an association between the teen's age. So usually, so if I go back to here, more parents are probably going to tend to check on their teens' internet usage when they are younger compared to when they are no longer a teenager. So we would say for this, based on what we see here, it's almost a 2-to-1 ratio. So moving on to our second example here. A study asked residents in the 3 cities whether they had a broadband connection. The results are recorded in the table. Organize the data in a relative frequency table and interpret the data. Write your answers as percents rounded to the nearest 10th of a percent. So the same thing as what we just did. So here we have our table here, all created. Now we're going to just find the relative frequency of that. So I'm going to write that on this other side, on the next slide here. So first off, or the total would be 3621. So we have 730 divided by 3621. This is going to, and I'm going to multiply this by 100. This is going to give us 20.2. And I'm just going to keep this on this slide. If you want to put it on the next slide, you may do so. But to save some time here, I'm just going to put it on this slide. Divide this by 3621. So 313 divided by 3621 gives us roughly 8.6%. Divide this by 3621. So 1043 divided by 3621 gives us 28.8, which if you add the 20.2 and the 8.6, you get 28.8. So the same thing here, 3621. 666 divided by 3621 gives us 18.4. 721 divided by 3621 gives us 19.9. If I were to add those together, so 18.4 plus 19.9 gives us 38.3%. 619 divided by 36.21 or 3621 gives us 17.1. 572 divided by 3621 gives us 15.8. And if you did 17.1 plus 15.8, we get 32.9. Then we can just add straight down to get our total. So 20.2 plus 18.4 plus 17.1 gives us a total of 55.7. I'm just writing the 3621 underneath here, even though I don't have to do that. 8.6 plus 19.9 plus 15.8 should give us 44.3. This should equal 100%. 55.7 plus 44.3 does give us 100. Now to interpret this. Do more cities have broadband connection or not? So what percent of cities have broadband connection? I go back to here, broadband connection, 55.7%. 55.7% of the cities have that compared to 44.3% who do not. Next, example 3. According to the U.S. Census Bureau, voter turnout describes how many eligible voters show up to vote in an election. The table shows the number of eligible voters who did and did not vote in 2012, the oldest and youngest eligible age groups. Organize the data in a conditional relative frequency table by age group and interpret the data. So here are the data that they provided for us. It's already in a two-way frequency table. What we need to do is find the conditional relative frequency. And for the conditional relative frequency, we're going to just go by row, and we're going to divide that by the total. So earlier on, when the first time I went through the table, I ended up putting the conditional one instead of the relative frequency. So here, I'm going to divide everything by 25,790. Okay, so I just want to find out those from ages 18 to 24. What was their percent turnout? So the percent of those who voted. So if I do 12,515 divided by 25,790, I end up with, I'm going to put this on the next slide here, gives me 48.5%. Next, 13,275 divided by 25,790 gives us 51.5%. And if I were to add those, them up, so 51.5 plus 48.5, this would give us 100%. 75 and older. And we're going to divide these by 16,724. So we have 11,344 divided by 16,724. That gives us 67.8%. Next, 5,380 divided by 16,724. That gives us a total of 32,000 or 32.2%. And if you were to add those straight across, that should equal 100%. So 67.8 plus 32.2 also gives us 100%. Which age group has a higher voter turnout? So if we go back to here, which group has a higher percent of those that voted? We would say the 75 and older had a higher higher average. So 75 plus and better turnout. Next, if the condition for the relative frequency table were whether a person had voted or not rather than the age group, the joint frequency for people between ages of 18 and 24 who voted would be 52.5%. If someone claims that this indicates 52.5 of all people who voted in the 2012 election were between the ages of 18 and 24, would they be correct and justify your argument? This would not be correct because that 52.5% is only talking about all those people 18 to 24, not the whole amount of people who voted. Okay, so this is only talking amongst just 18 to 24-year-olds. So only 52.5% of 18 to 24-year-olds voted. So that's not half of the people who voted in there. This is just talking about one subgroup of it. Next one, the Bureau of Labor Statistics finds and records data about people who work in the U.S. The table includes estimates for the number of employed, salaried workers and self-employed workers in agricultural and non-agricultural jobs. Organize the data in a conditional relative frequency table by agricultural and non-agricultural jobs and interpret the data. Write your answers as percents rounded to the nearest tenth of a percent. So here we have our data here, and we're going to do conditional, so you're just going by row itself. So here, divide this by the total, which is 139,770. We're going to divide everything by 139,770. So this first one, 1687 divided by 139,770. That would give us 1.2%. Next, we have 138,083 divided by 139,770. And this will give us 98.8%, which will give us a total of 100% for salaried workers. Self-employed, here we're going to divide this by 9,732. So 952 divided by 9732 gives us an answer of 9.8%. And for this one, we know that this has to equal 100%. So I could actually take the 100% minus the 9.8%, and that would give me 90.2% for this one. But just to verify it, if I go back and did 8780 divided by 9732, multiply it by 100, I would get 90.2. Now the totals, if I add straight down, this would give us 11%. This will give us 189%. And over here would give us the 200%. Now, which group has more employees for agricultural and non-agricultural jobs? So if I go to here, so employees, so if I look at the total, we would have more salaried workers for non-agricultural jobs. One thing I just realized, this one tells us to do, you're comparing agricultural and non-agricultural. This one is slightly different than the ones with the teens because we were comparing the age groups. which the age groups were on the sides here. So these are actually incorrect. So let's go back to the original one here. So we are comparing going down vertically. So I'm going to have to divide by the totals of each one of these. So this one, I'm going to divide this by 2639. And these are going to be divided by 146,863. So now if I take this 1687 divided by 2639 times 100, that would make more sense for our answer to be 63.9%. Self-employed would be 952 divided by 2639. That would give us 36.1%. And the total should be 100% down here. And we don't want that to be more than 100%. So when you're talking about just all agricultural, they should add up to 100%. Now the non-agricultural, we would take the 138,083 divided by 146,863, multiply it by 100, you would get 94%. And then we'd have 8780 divided by 146,863, multiply it by 100, we would get roughly 6%, which will make this 100%. And if I were to add straight across for this one, let's see, 94% plus 63.9%. We won't have to worry about this column right here. So now we can go about answering the question, which is which group has more employees for agricultural and non-agricultural jobs? So you're comparing agricultural and non-agricultural, the number of jobs here. So when you look at that, most of the workers are in salaried agricultural and non-agricultural workers. So that's where most of the workers are be. So they would be salaried workers for ag and non-agricultural. The last part, the exit tickets, we're not going to go through there. You may go through those if you want to look for more examples. Otherwise, that is our lesson 11-2.